Okay, so in this section we're going to talk about power series and looking at power series solutions to differential equations. So let's first review what a power series is. So if you have, say, f equal to summation n equals 0 to infinity a n x minus c to the n, this would mean, so you stick in 0, then stick in 1 in place of n and so forth. So putting in 0 would be a of 0. Next term would be a1 plus x minus c. Then it'll be a2 x minus c squared and so forth. This is a power series centered at c. So let me list a few power series that you should know from Calculus 2. Okay, so here are some important series. You have the series for e to the x, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so forth. So this, in summation notation, this is how you'd write it. And the interval of convergence for this guy is all x's. Then the cosine is picking up the even terms with the alternating plus and minus, so it'll be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. That'll be minus x to the 6 over 6 factorial, going back and forth like that. And this is also converges for all x. Sine similar, just picking up the odd terms. And then you have the power series for inverse tangent. So it's this guy here, x minus x cubed over 3 plus x to the 5th over 5. Summation notation written like this. This just converges this series between negative 1 and 1. And the last one I have here, the ln of 1 plus x, that's going to be x plus x squared over 2 plus x cubed over 3. So in summation notation, it would be negative 1 to the n plus 1, x to the n over n. And that's also just defined between negative 1 and 1. Okay, so there's other important ones too, but these are the main ones from Calculus 2. Alright, so let's continue. So I'm out of space here, so let me erase a few things and I'll keep going. Okay, so the ratio test, if you recall from Calculus 2, says that the series converges absolutely if the ratio of an plus 1 over an absolute value, this limit, is less than 1. Okay, so let's take a look at an example now. This is practice quiz 6 number 2. It says use the ratio test to find the interval of convergence, and here's our series. Y equals summation n equals 0 to infinity negative 1 to the n x to the 2n, and on the bottom divided by 2 to the 2n times n factorial squared. So this guy right here is my an. Okay, so it's my an. Now to find the an plus 1, we're just going to replace all the n's with n plus 1's here. So let me write that right here. Okay, so my an plus 1, so again I'm going to replace all the n's over here with n plus 1. So replacing this with n plus 1, negative 1 to the n plus 1. Replacing this with n plus 1, we'll have x to the 2 times n plus 1. Replacing this with n plus 1, I've done that here. And replacing this with n plus 1, I've done that here. And let's recall, actually now let's look at the ratio of these two things. So doing that we have, okay, so looking at an plus 1 over an. So here's my an plus 1 here. And we're dividing it by an. That's the same as multiplying it by the reciprocal of an. So therefore, turn this guy around here. That's what I've done here. So that'd be 2 to the 2n, n factorial squared on top, and this guy on the bottom. And now we want to simplify this and find the limit. And we know if it's less than 1, then it converges absolutely. Okay, so, well actually we're going to set it less than 1 here to find the interval of convergence. So we'll say less than 1 here. And we'll find conditions on x that make that true. Okay, so we want to simplify this, so let's make some observations. So note. Okay, so let's recall the definition of n factorial. So n factorial would mean n times n minus 1 times n minus 2 all the way down to 1. So for example, 3 factorial would be 3 times 2 times 1, which would be 6. 4 factorial will be 4 times 3 times 2 times 1, which would be 24. So note here 4 factorial would be 4 times 3 times 2 times 1, which is 24. But you can also think of it as 4 times 3 factorial, because this part here is 3 factorial. So you can write it as 4 times 3 factorial. So 4 times 3 factorial. So in general, n plus 1 factorial then, by definition, it's n plus 1 times n minus 1 all the way down to 1. You can think of that as, because this part here is n factorial, so you can think of it as n plus 1 times n factorial. That's how we're going to simplify this guy here. Okay, so I'm out of space here, so let me erase a few things and we'll keep going. Okay, so as we mentioned before, the n plus 1 factorial can be written as n plus 1 times n factorial. Also, minus 1 to the n plus 1 can be written as minus 1 to the n times minus 1. And x to the 2 times n plus 1 power can be broken down as x to the 2n times x squared. And 2 to the 2n plus 1 can be written as 2 to the 2n times 2 squared. Okay, I'm going to make those substitutions now over here for these guys, and then simplify this. We want this to be less than 1, so it converges by a ratio test, and we'll then find the interval of convergence. So making these substitutions over here, we get then. Okay, so making the substitutions then, so in place of minus 1 to the n plus 1, I wrote minus 1 to the n times minus 1. In place of x to the 2n plus 1, I wrote as x to the 2n times x squared. Down here, I wrote this guy as 2 to the 2n times 2 squared. And the n plus 1 factorial, as we set up here, can be written as n plus 1 times n factorial. We're squaring that, so therefore you'd square the n plus 1 and you could square the n factorial, which I've done here. This guy stays the same. And you can see now a lot of things will cancel. So in particular, the x to the 2n's will cancel here. Minus 1 to the n's will cancel here and here. 2 to the 2n will cancel here and here. N plus 1 factorial will cancel here and here. So what we're left with is then the following. So simplifying will be limit then. So let's have a negative x squared left on top and a 4 n plus 1 squared on the bottom. Absolute value of this. Now the limit here, I'm not writing it, but it's n goes infinity is and all these guys. So the x is some fixed number, but the limit, the n is going to infinity. Okay, so then this was the same as this guy, because the x squared is positive, the n plus 1 squared is positive. I can pull the x squared out because it's not part of the limit. Then if I take limit of 1 over 4 to the n plus 1 squared, this is getting larger and larger because the limit's n goes to infinity. So it'll be 1 over a large number, which is going to 0. So x squared times 0 is 0. So therefore it's going to equal 0, which is less than 1 for all x. So therefore we can say then that the interval of convergence will be all real numbers. So let me write that here. So hence the interval of convergence is negative infinity to infinity, or all real numbers. Again, we can say that because this limit we've shown is 0, and by the ratio test we know it converges whenever this limit is less than 1, but it's 0, which is less than 1, and this is true for all x. So there's going to converge for all x. Okay, so we're done with the question. So I'm going to leave the video here. We'll continue in the next video verifying that a power series is a solution of a differential equation. So we'll look at an example doing that in the next video. Okay, so let's leave it there.